Welcome back. I'm Chris Sikora, and I'm going to step you through an introduction to assemblies in Creo Parametric 6.0. This exercise, we're going to take a look at what you see there up on the screen. It's really just a widget. It has a mechanism inside there. The idea is we should be able to go in and rotate it once we're done. And the rotation here is known as like dynamic assembly motion. So we're going to take a look at how to achieve that. Now, you don't have to get it like that. A lot of the assemblies that I made when I was in industry, there wasn't dynamic assembly motion with them. For example, a cell phone, there's not really many, if any, mechanisms in there. It's all solid state electronics. So be aware, you're not going to always have to assemble it in the way that I'm showing you. But let's go ahead and take a look. First of all, we need to access the files. So if you want, you could go to Google Chrome or to Firefox, whatever browser you're using, and type in V as in Victor, E-R, T as in Tom, A, N as in Nancy, U, X as in X-ray, 1, and .com. That should bring you to this page, and here you just go to Part Files. And in the white column are the files for Creo. So find the exercise 5 parts. Click on it. Now, it's going to prompt you to download it. You can click download here or up here, either one, and it will take a moment, and it's a compressed file format. So if you get this message, if you're using Chrome, it's a little bit different. It'll actually show you the files internally. You can select them, but here we could say open with Windows Explorer or save the file. I would just open with Explorer, and there they are. Now you could extract them all using this tool inside Windows, or what I do, I just go ahead and select this, or Control A will select them all, and then hold Control and hit C for copy. Now go to your Creo folder, which we made, and right click and go to New and Folder, and then name that folder E5, and then double click on the E5. And I've already dropped it in here. You just click in there and hit Control V as in Victor, and it will paste them inside there. And then you'll have the files you need for this exercise. Now, if you like, there is a training guide under instructional manuals and the Creo Parametric 6.0. And we don't really need it for this one. This is more of a video instruction. This does give you some of the basics, but not everything that you're going to need as far as working in here. So the video is your best bet. Okay, so now we're going to start up at the top here, New, and select Assembly and label this capital E1 for Exercise 1, and hit OK. And you'll see an assembly file looks almost virtually identical to a part file. Now I've turned off my plain display. I'm going to turn it back on. You could even turn on the CSYS. Okay, and another setting, those of you who have pretty decent computers might want to change on your system. If you go to File, and if you go to Options, I noticed that on faster computers, this actually pauses it a little bit, slowing it down. The intention was actually to speed things up. It simplifies your model. But if you go to, let's see here, Assembly, not assembly, let's see, model display. Yes, this one right here. I found by unchecking that use level of detail for the shaded model when manipulating the view, it actually sped things up. And I have a pretty decent computer. So be aware, it might be beneficial to leave that low. Also, if you're working with extremely large assemblies with more than 1,000 parts, I would leave that on. Because what it does is simplifies the model as it rotates, but that simplification comes with a price. Sometimes you're waiting around for a half second, and some of us like to be a little bit more rapid than that. But for this small of an assembly, it's not going to make a difference. In fact, it just speeds things up. So I'm going to hit cancel. But those of you who want to turn that off, you could hit OK. All right. Now you'll see that we have assembly right, top and front planes. You can sketch on those. In fact, they call something's called skeletal modeling, and where you're basically drawing out the skeleton of whatever mechanism that you so desire. And then you could build or assemble the parts around it. That's pretty advanced. It's in the top-down modeling arena. There's really two basics. There's top-down and bottom-up assembly modeling. What we're going to cover today is bottom-up. Now, the difference being, bottom-up is taking parts that are already built, like from a library, like nuts, bolts, washers, or in this case, actual individual models that were built outside of the assembly, and putting them together. This is actually the easiest format when the parts are already built. We're going to cover after the midterm, like around exercise 9, we're going to start covering top-down assembly modeling. And with the very basics, where we could build a part based off of another part. If one updates, or if you change the one part, the other will update with it. And that could be thousands of parts could update automatically. So you don't have to go into each one and make the change. So it's very powerful functionality built into this. There's also, in the latest version of Creo Parametric 7.0, you could do this from a part file now because they have multi-volume solids. So unfortunately, this is 6. It doesn't have that functionality built into it yet. But next year, I'll probably have the 7.0 videos for you to watch. And we'll take a look at that. But today is only bottom-up assembly modeling. Okay, so we already got the parts. So let's go to assemble right here. And that's where you go typically to drop in the parts. And you could see there's the parts. In my case, I actually directed it in advance to the location. So mine was in the demo, my computer, or my documents, Creo E5 folder. Otherwise, you have to locate it. So you could, you would go to that network. Oops, didn't want that. Okay, so basically, I just had to get out of that. Essentially, what I did here, if you need to locate where your stuff is, you could go to My Documents, and there's the Creo, just double click, and there's my E5 folder, and then our list of things. Now, there is a preview tool that enables you to see each part as you click on it here, and you could even spin and rotate them if you wanted to. We're actually looking for the Bracket Pro, so go ahead and select that, hit open. Now, what we're going to do is we want to locate this bracket locked into the origin of the assembly. Do we have to do that? No, this is just one technique. And you could see you have these little directional arrows. You could grab those and drag this and locate it. You could also define by planes. But what I'd like you to do in this case, for the very first part, and for the most part, for most of my lessons, instead of going to automatic, you're going to go to default. Now, if you could remember that, that's very important because on your midterm and your final, you're going to have to assemble some things. And so to make sure you select default. Otherwise, if you do automatic, it's not going to rest directly on the origin. I.e., what's happening is that every part file that I have here has its own origin, as we've seen in previous lessons. And that origin, remember, is the centralized point for where the planes intersect for the front, top, and right planes. So if you want to match that up, or at least the strategy is, it's a good strategy, I believe, to actually match those up for many assemblies and such, if you can. And so that's essentially what we're doing. We're just matching those things up here, at least for the first part. The other parts we're not going to be concerned about so much. All right, so I went with default and hit OK. Just remember that. You don't want to go with automatic typically, at least for my lessons. All right, also, I'm going to turn off the planes. Now, be aware you can mate up the planes. We're not going to do that, though, so I'm going to disable that. Also, I'll turn off my CSYS. Now, I'm going to go ahead and assemble another part. So I go to Assemble, and this next part we're looking for is the yoke male. And there you can actually see it. Hit Open. And you can move this over here and up. Now, when we want to start mating things, you'll notice there's automatic and there's some settings there. We'll cover that shortly, but the easiest way, in my opinion, is, okay, we know this post needs to rest inside that pink hole that we see there. So go ahead and select this face. And if you have to zoom up as close as you can. Select one of those faces. And now move your pointer over this salmon colored surface and click. And it will align itself. Now look at what we've done actually. You could grab the arrow, the green arrow there, and drag it up and down. So in the Z direction, it's still active. And we could spin it around with that wheel. But once the arrows and the wheels turn white, that means it's fully defined, or it's defined at least with those degrees of freedom. Now remember, with degrees of freedom, there's a total of 6 degrees of freedom typically. The first 3 are X, Y, and Z. And then each one of those, the other 3, are the rotation around X, Y, and Z. So that creates 6 degrees of freedom. And essentially by selecting some of these faces and edges and things like that, we'll learn how to remove those degrees of freedom to lock it into place accurately. Okay, and we don't want to fully lock this, but partially. Now, when you add that first one in, it's very important not to apply it yet. If you want dynamic assembly motion, which is what you saw earlier where I had the ability to grab the handle and rotate, then this is what you need to do. Go to the Placement tab, and there you'll see the faces that you selected and the coincident relationship it automatically selected for us. That's a little expert system that's built in there, or AI, what we call AI these days. Now, it was pretty smart in selecting that. That's good. But what we need to do here, and it didn't come up automatically. Let's see here. Let's hit New Constraint. Okay. And now we're going to go ahead and select this top face here, rotate to the underside, and select this face right there. Here's what I was waiting for, and I might have bypassed it the first time around. Make sure you turn off Allow Assumptions. If you leave it on, it's fine if you don't care about dynamic assembly motion. And like I said, a lot of things don't require it. But in this case, I want to show it to you because it's pretty neat. So turn off Allow Assumptions. Now, if you neglect to turn it off with the first feature, it'll add it automatically for every single one. So it's locking it down is what it's doing basically, which is many of the time that's what you want. Much of the time that's what you want. Go ahead and hit OK. Now let's try and rotate this. So go to the drag component up here. See that little hand? Click on it and click on this part here. And now you'll notice you could spin or move your mouse in like a circular motion, and you could see the actual parts moving. Now, those degrees of freedom for vertical, horizontal, and rotation and the other axes isn't there. We only have 1 degree of freedom. That's just spinning around the center axis. Okay, see this little keyway, the yellow keyway? Face that to the left, or to the front of this, and click. The middle click 2 times. Middle click is click on that mouse button 2 times and release it. That exits you out of that rotation tool, which is the drag component. Let's add some more parts. Let's go to Assemble again, and this time we're looking for the spider hinge. Right there, click on a spider hinge, open it up, and it's not a bad idea to get it close in proximity to where you want it, just by using those drag handles. Do you have to do that? No, but remember, when you select faces, you want to be zoomed up, so usually it's not a bad idea to get them close in proximity to one another so that you can zoom up and then go ahead and select the faces you need. All right, we're going to go ahead and select this hole right here, and that hole looks as though it aligns really well with this hole over here on the yoke. Go ahead and select that surface. And now it's aligned at coincident. Again, the expert system did a pretty good job of selecting what we wanted. All right, and let's just go to Placement and make sure. Now, we look good. There's no issue there. Let's go to New Constraint, and now select this face here, the flat face. Now, don't get lazy and think you could select that face, because you know what? It's going to push this block out. You want to rotate with the middle mouse wheel. Hold it down and rotate, and get to the face directly parallel to it on this side. Select it. And again, it picked coincident for us, and it put it right between the legs. So it's actually a good fit. Hit OK. Now, if you want to test this, go to Drag Components, and you could click on this part. You'll see it will spin, and it will rotate around. Middle click. And get it, again, and this looks fine. Should be fine that way. All right, now let's go to Assemble again. And this time we're looking for the yoke female. hit open, and get that close to this area here. And let's get the holes aligned. So this hole here, and then the hole that's, here's the red face that's perpendicular to the red face there. Select this. And now we could select this face of the leg of the yoke female to this opposite face. Now, if you're not rotating, you're not doing it right. You have to rotate it. Otherwise, it will be on the outside. And if you ever mess this up, my suggestion is new users, until you get more fluid with it, is just cancel out of it and reinsert it and try it again. You might have to try it several times. It takes a little bit of getting used to. Okay, so we have that now. And you'll see you could still rotate this wheel a little bit. So we haven't removed all the degrees of freedom. And now we're going to go ahead and select this face. Now, be aware you could go through the placement and go to new constraint as well. It automatically does it, and it does a nice job automatically these days. So let's go ahead and select this face here and this face here. Now, it's given us an angle offset. And that's not really what we wanted here. We actually want it to be parallel because there is a distance gap. Now, if it knew it could actually close that gap automatically where there's face-to-face contact, the AI would have selected coincident for us, but it knew better not to. So it gave us an angle. But we actually want to select parallel. Now, the preview with parallel doesn't always update to where you see it. So you have to just kind of hit the green check mark. And there it should align. Now let's test this out. Let's go to drag component. Click on that little face right there and rotate it. And look at that. Our U-joint is actually functional. Now be aware this dynamic assembly motion is just dynamics. It's not the kinematics that you know that is actually in there. You could actually get the kinematics and dynamics package for this software that would enable you to test things like friction and moments of inertia and things like that. So just be aware this is just strictly dynamics. It's not giving us any momentum or anything like that. Okay, so anyhow, but still pretty impressive how easy it is to set up, in my opinion. All right, let's now go to assemble. We're going to bring in a red pin. So let's go to the red pin, hit open. Now, those of you who are still stuck on the other one, just if it's stuck there, remember you could cancel out, or you could click on the part, hit delete on your keyboard, try reinserting it, back up my video and watch it again, because I do this one in class, and there are students who get left behind a little bit. Just note, this is a video. You could go back and just take your time and get it right. Okay, now I'm going to go ahead and select the length of the shaft to the red hole. Because remember, it's the red pin to the red hole. The blue pins will be to the blue holes. Okay, now that we have this, we want to sink it in there. So you could select this face right here and select the red flat face. Now, what we're going to do, we could drag it in until we get it to where we like it. In fact, actually, what's really kind of neat, it seems to always, it did this a second time today for me. It snapped in almost perfectly. It should be like 0.062. And then it should be like flush with the outside. Go ahead and hit OK. And again, if you just want to test it, you don't have to test it every time, but it's a good measure. Now, I'm going to let you put in the other two blue pins. That's part of your lab, one of your labs there. Put the blue pins in on both sides, so you're going to have to insert twice. There are also some set screws at the bottom, so let's go ahead, go to assemble, we'll get the set screws in. And it's just the Fastener Pro. Hit open, and there it is. Let's get it close. Zoom up and rotate. I'm going to rotate this so the actual socket is on the outside. Now I'm going to select this face here to this face, and then we have to locate. There it is. Let's drag it in close to proximity and then zoom up again. I'm just using my wheel on my mouse to do the zoom. Now this face to this face, and it went coincident automatically. Now, just those of you who've used earlier versions, they have really improved this from what I can tell. It seems to really be working very smooth. So those of you at PTC Creo, those of you who've been working on this, thank you. It's actually really pretty cool. All right, hit OK. Again, your assignment to put those others in as well. Okay, now we're going to go ahead and go to Assemble. And this time we're looking for the handle sub, which is a sub-assembly. That's why it's called handle sub. Now a sub-assembly is another assembly, basically. That has, in this case, it has a couple parts. We could hit the little arrow here on the feature tree, or the model tree, sorry, and you can see the handle shaft and the handle crank. Let's go ahead and align these. So you can actually select the inside or the outside. It doesn't matter of that hole. Just make sure you don't select that flat there. And then select the shaft on the yoke. Now let's go and align this flat here. So zoom up and get the flat. Stay away from this radius. That'll do something that we don't want if we select that. So this face here to this face right here. Okay, and that aligns the key. Now, literally in real life, if you didn't have a key, it would spin around. It will actually do that same thing if you don't have a keyway in there. So it's pretty neat that mechanically it is somewhat functional here. Okay, so now we're going to go ahead and select this face to the top face. Now, notice it didn't go coincident, so it didn't slap it up there. And that's fine, actually, because we want to put in a little distance gap. Now, remember, when you design things, there are, by default, distance gaps on almost everything. Very rarely do you design coincident, like line to line. Like if a bolt diameter should never be the exact same size, or I should say a pin diameter should never be the same size as a hole, especially steel or metals. It's not going to work. Plastic, sometimes you could get away with it if it's flexible and thin, but no, you should always design with the tolerance built in. So here, let's put in 0.005, so 5,000ths of an inch, hit the green check, and we basically put in that little distance gap right there. Can you see in between there? There it is. So that's a bit more realistic than coincident all the time. One reason I use coincident is just because I'm just trying to teach you the foundations. And when you start adding tolerances to everything, it confuses students sometimes to have to enter numbers. But later on, as we get more advanced, just note in real life, you're going to have to put in tolerances like that. Okay, now let's go ahead and test this out. Go to drag component, click on the handle, and there it is. Okay, so that's exercise 5. And remember, don't forget to put in the extra set screws. There's 3 of them, and then you're going to have to put in 2 of the blue pins. So I'll just go right here. I'll just show you really quick the blue pin because I didn't bring one in. Find the blue pin, open it, get it close where you want it just by grabbing the handles. We'll rotate it a little bit in there, select this face to the blue face, drag that out, and then this face here to the blue surface there, and get that out there. Oh, did we not get that? Try that again. Now let's do a new constraint here. This face to this face, and set it, instead of coincident, we want by distance. Let's try dragging it out. There, 0.063. That's actually just right on task there. Nice job. Okay, so hit the green check. So just be aware you could add those in similarly. Okay, now let's go ahead and we're going to drop in the next, we'll look at the next assembly. So for this one, let's go back to the Vertanic 1, go to Part Files, and you're looking for the Lab 5 parts. Go ahead and select Lab 5 parts, download, and OK. And actually, this isn't a subfolder. I should have actually did this with all the parts, so you could just grab the folder so you don't have to make a new folder. Watch this. You just right-click on this L5 Creo, hit Copy, and then go to your Documents, Creo, right-click, Paste. I'll probably have to do that one of these days and update all those like this. And now we have a folder, and look at that. We have all of our parts. Okay, now you'll notice this is based off of the lab 4 that you did last week. So if you want, you could use your part and test it out to see how well it fits together. If it doesn't fit, that would be an indicator that you didn't design it right. So it's actually a good way to check your work and learn something new. So let's go to New, Assembly, and this is L5B. Now you might say, well, where was L5A? Lab 5A I took out. It was too primitive and basic, and I just wanted to do something a little more interesting. So Lab 5B, hit OK. I might drop it back in there one of these days, but in the interim, no. Okay, now we've got our assembly. Let's go to Assemble and go back to the Creo and find the L5 Creo 2. And we're looking for the, let's drop in the rear bezel first. And remember, there's, instead of automatic, go with default. Try and remember that one because you're going to use it on almost all the assemblies we do in this class. Hit OK, and remember that aligns the origins or the CSYSs. All right, now we go to Assemble. Let's bring in the PC board. Get that over here. And we'll go ahead and select the underside face, and we want it to rest on this little surface there. And we could go with coincident in this case. And now let's get this hole line. Now be careful, there's two sets of holes here. One, that's going to be for the light frame. We don't want that. We actually want this second one here, the smaller one. Select that to this face here. And then we need one more. So just to make sure it doesn't disalign. So this face here to that face there. There we go. Okay, and I think we're good. Let's hit apply. Okay, now we're going to go ahead and drop in more parts. So let's go to Assemble, and let's get that, let's see here, the battery shield first. Let's drop that in, get that up here, select this face to make it concentric to the outside here, and then the underside face coincident to this face. And so change it from distance to coincident. Hit OK. Now notice one thing I didn't do is I didn't set that allow assumptions. I didn't turn it off. I'm actually allowing it to allow assumptions. I want allow assumptions in here. I want everything locked down. There's no mechanical parts in here that are going to interact. So that's why it's not necessary for this one. But again, dynamic assembly motion, we would check that. And, we'll see that in a second. Okay, let's move on to the next one. Assemble. Now we're going to go ahead and get the battery. Let's see. Open that up. Get that over here. We'll select this face to this to make it concentric. And then the underside face to this face here and make it coincident. Now, okay, so now I want to show you how to pattern this battery. So over here, select the battery, the 2013 part there, and find pattern up here. If pattern isn't highlighted, you have to make sure you hit escape a couple times and try hitting that battery again from the model tree. Go to pattern, and instead of fill, we want direction. Now for the direction, we need to select like a vector. So this vertical edge should work for us because that's how it's going to stack along that edge. Now we need to flip it because see the arrow is pointing down. So flip it so that the arrow is pointing up, and the flip switch is right up here. Now we need 4 instances, and it's inclusive of the one that's already there. And then the spacing should be 0.06. And now you should be able to hit the green check and hit OK, and they're all stacked now. So that's an assembly pattern. Now we're going to drop in another part. And you could do them individually if you want. It's good practice either way. All right, now the battery connector goes on top here. So let's get that over here. And again, concentric to any of these. Oops. And I think I didn't want that. So let's see here. Let's cancel that. Now here's the thing. If you want to cancel it, when you hit yes, it removes the part, which is actually really nice. Let's try doing that again. Assemble, battery connector, open, get that up here, select this face, and now be careful because it's selecting through, which can be helpful, but not in this case. We want the outside cylindrical surface here, or it could be the outside of one of the batteries. Just make sure it highlights in orange first. Okay, now we can drag it down a little bit. Let's select the underside face of it, rotate to the top face there, and make that coincident. Now we could bring in the light frame. So let's go to Assemble and find the light frame, open that up, bring that over here. Now there's two posts, or the center even we could align to, but let's do the post though. So this post to this hole right here. And then let's get the other post to the other hole. So that post to this hole here. Now I don't have the fasteners included for this one. So don't worry about it. And to this face, and we'll make that coincident. There it is. All right, and it's supposed to be transparent. Okay, now let's bring in the last part, which is the front bezel. Now again, if you want to try your L4 and pop it on here, see if it fits, you can. There are some additional features that I put in on here that you don't have on the drawing. So beware, it should fit visually, but inside there's probably going to be a few interferences. That's okay. All right, hit open here. I'll move this over here. Move that there. And let's go ahead. I'm going to align this little face right here, which is the top of that boss, to this step right here. And make that coincident. Okay. Now let's see if we could do the chamfer. Let's see, from here to the chamfer here. Nice job. Okay, and let's see if we could do this chamfer here to this one here. We got it. Very nice. Very nice indeed. Okay, now to explode this. Now exploded views, you're going to need to know how to do this for your midterm. Now you have edit position or explode. We could go to edit position first. Now it has this kind of auto explode here, and it actually aligned them pretty decent, just not how we'd want exactly, but we can modify. So we could click on a part here, and you see the drag handles. Let's drag that forward a little bit. And so it's kind of nice. It moved them in a position that is quite friendly to what we would expect or hope for. We could leave the batteries stacked. It seemed to have separated a lot of those things pretty darn well for us. But no, it's just a matter of clicking on them. If you wanted to individually do them too, you could. If you hold Control, you can select multiple parts to move. And then the next part here. And let's say you want to break these up. Again, good practice. And then go ahead and hit OK. Now to collapse it, you click on Exploded View again. Now, by the way, notice how mine are all aligned almost perfectly. If any of yours are darting out to the side, that's an indication that you didn't fully define it with constraints. So you were probably missing some sort of constraint on there. So if you go back and check those out, you should be able to find probably where it is, I would hope. You could go to the move or drag component, although actually it allowed assumptions, so most likely not. So just make sure you don't have that. As we get more in advance, we'll see how to update and change those things. But I'm going to turn off Exploded View, and you'll see it will collapse. And now to save this, I'm going to go to File, Save As, Backup. and just hit OK here. All right. So there you can see assemblies, and that concludes this exercise.